All right, so for homework 6.4, sorry, 4.6.2, first we're gonna do question 20. Question 20 says from this function right here, I need to find the integral of the function. So the first thing I need to do is use long division because I need to take the denominator and divide by the numerator. So come over here like that, do x squared minus 5, x cubed minus 4x squared minus 4x plus 20. And then first thing I do is I figure out how many times do I have to multiply this front x to get x cubed, so just by x. And then so when I multiply x times x squared, I get x cubed, and then x times negative 5 equals negative 5x. So instead of putting that with x squared, I put that with the 4x, so it'd be negative 5x. Boom. And then I subtract that, this 0, this comes down to be this comes, oh no, oof. Okay. Okay, that's better. Okay, that's better. This comes down to be negative 4x squared still. But these, since it's a minus 5 minus, that's a plus. So now I got plus x. And then I get plus 20. That just comes down. And now I come back here. How many times do I have to multiply x squared to get negative 4x squared down to 0? For this one, I need to multiply it by negative 4. So, minus 4. And so what I do now is I see x times x. I'm sorry, negative 4 times x squared is negative 4x squared. And then negative 4 times negative 5 equals 20. Oh my goodness, that's so crazy. They add up. And so I subtract this. This equals 0. This comes down to x. This equals 0. So then you're just left with the remainder of x. So when I rewrite my integral, it is x times wait, check that. Okay, it is x minus 4 plus x over what you're dividing by, x squared minus 5. And then I take the integral of this, but I can simplify this right here by, well, first I simplify this. So it's integral of x minus the integral of 4 plus the integral of x times the integral of wait, no, it's just the integral of, sorry, it's the integral of that, this one right here. So it's the integral of x times 1 over x squared minus 5. So first I'm going to do this segment right here. So the first thing I need to do is for the x, I use the power rule. So this x is the first, so x to the first plus 1 is 2, and I put that number in the denominator. So it's x squared over 2. And then for 4, the integral of 4 is 4x, using the constant rule. So it's minus 4x. And now I come over and do this segment right here. For this segment, I use the chain rule. And so, in order to do that, I make my u equal x squared minus 5. And the derivative of that is 2x. And then to get the dx, I'm going to divide by 2 and multiply by dx. So then I'd get du over 2 equals x dx. And so then I come over here again and I plug this back into the integral, so then it'd be 1/2. It would be 1/2 1 over u du, and then this would equal 1/2 natural log of x squared minus 5 plus c. This over here would be plus c as well. Okay, now I come down here and I write out my current function. So now I've got x squared over 2 minus 4x plus 1/2 ln of 5x. Whoops, not 5x. Oopsie daisies. X squared minus 5 plus c. And if I look at all these, they're all divided by 1/2, or multiplied by 1/2, or divided by 2. And over here, I can just change this up by multiplying this number right here by 2 to make everything divided by 2, essentially. So I can simplify this down by saying x squared minus 8x plus ln x squared minus 5 over 2 plus c. And that is my answer for problem 20. Problem 72 says to find the region of the equation, find the area of this region of this equation. The equation is y equals 5x over x squared plus 2 for the points from x equals 1 to x equals 5, and then y equals 0. So first off, with the 2 points, point A and point B, I can put this into a definite integral. So from 5 and 1, 5x over x squared plus 2. And then the next thing I do is I simplify this down. So this is technically 5 times x times 1 over x squared plus 2. So I can just move the 5 to the outside. So then that equals, oops, dx. So that equals 5 times 5 and then 1, 5x over x squared plus, whoops, not 5x, silly me. X times 1 over x squared plus 2. Now looking at this, I can use the log formula to figure this inside part of the problem out. So let's make u equal to x squared plus 2. From this, I can deduce that 1/2 du equals x dx, because using the power rule, x derivative of x is 2x. So 1/2 du equals x dx. And now from this point, I can plug this back into the equation, so I can replace the x with 1/2 du. So I end up moving the 1/2 to the outside. So then this right here turns into 5 over 2. Right now, since we put in a u, we don't know what these are. We don't need to find them because I'm doing it a different way. 1 over u du. Boom. And now with this, I can see this is natural log. So I can just use the natural log formula and plug in the u where the u is needed. So it's 5 over 2 times natural log of u, which is x squared plus 2. Boom. Right there. And that's for the points from 5 to 1. So now I plug these back in, because right here we would have needed to solve for u, but I don't want to do that. So what I do now is I now plug in 5. When I plug in 5 to this equation, 5 times 5 equals 25 plus 2 equals 27. So 5 over 2 times the natural log of 27 is about 8.24. And then that is subtracted by when I plug in 1. So 1 times 1 equals 1 plus 2 equals 3. 5 over 2 times the natural log of 3 is about 2.75. And when I subtract those, I should get about 5.4931, which is my answer of this problem. Alright, so for the final problem, 95, it asks me to find the definite integral f of x equals 2x ln x over x for the interval 1 to e So the first thing I do, I know since this is interval 1 to e, e's b and 1's a. So I go like this, e and then 1, and then I put in my function, 2 ln x over x. Now this is just 2, so that goes on the outside pretty much. So 2 e and then 1, and then ln x times 1 over x. Boom, boom. Now what I do is I let u equal to ln x, because this is chain rule, right? So u equals ln x, and from this I know that ln x, derivative of ln x is 1 over x. So du equals 1 over x dx, and then from here I can cancel out the 1 over x and the dx right here for du. So then it just equals 2. I don't know what these are because I'm putting in u du, right? And then in order to find the integral of this is u to the power of 1, so I use the power rule. So so 1 plus 1 equals 2, so it's u to the power of 2 over 2 times 2. And you bring up 2 to the numerator, and then you cancel out the denominator, so you end up with u squared. And then from there, I still need to find the integral. I mean, not the integral. I need to find, yeah, check that. I still need to find the integral, essentially. So what I do now is, oh dear, u squared. Now what I do is, from here, I find the integral. U squared is ln squared x. Boom. And now, after this, I plug in e and 1, and that equals 1. So you plug in e, natural log of e is 1, and then 1 times 1 is 1, and then when you plug it, natural log of 1 is 0, 0 times 0 is 0, so 1 minus 0 equals 1. And now to find the average, it was supposed to say average here, average. It wants me to find the average area, not just regular area. Man, I described that really bad. Okay, and so what I do now is I multiply 1 times 1 over b minus a, e minus 1, and that equals 1 over e minus 1, which is about 0.58.